Welcome everybody. It's great to see you here. Very soon we'll get started with the session. Welcome everybody to this Cropping Conversation Ask Me Anything session with Graeme Sait. My name's James Dyack and I'm the Farmer Engagement Manager at Soils for Life. And this Cropping Conversation is part of our Cropping Resilience project. And I'll share just a little bit about the project in a minute. But for those of you who don't know about Soils for Life, we are a small not-for-profit organisation. We have just about 6 equivalent full-time staff and cover the whole of Australia in our work, which focuses on supporting Australian farmers to regenerate soils. The Cropping Resilience Project, which this session is part of, is our major project at the moment, and it aims to support the growing cohort of Australian croppers who are applying regenerative practices, and we're producing 10 practice guides in this project and an amazing set of resources. So I hope you enjoy this session and you come along to our other sessions. We've got an amazing lineup of specialists focusing on different aspects of cropping. So please look out for the next sessions over the next few weeks. The purpose of this session is to answer questions. Here's some pictures of some of the practice guides we've been producing. The purpose is to answer questions from Graeme. Graeme's going to talk for about 14 minutes, and then we're going to go through questions from you. So start thinking of your questions that you'd like to ask in the presentation, and don't be shy. The sessions are here for you, and if you've got questions, pop them in the chat bar. Try to make sure that the questions are brief and be mindful of allowing everybody to have a chance. So please be on mute when you're not talking, but it is great if you can leave your video on, because it really helps us with our work and our presentations, so we can see your faces, we can see how you are enjoying the process. So that helps us. We'd encourage you to do that if you can. And this is just a 1-hour session, so we'll be working to keep everybody to time. So do forgive us in advance if we cut the conversation short. We might have to interrupt to do that. But this session is with Graeme. So we're just going to introduce Graeme for those of you who don't know. He's Graeme Sait's a renowned author and educator, the founder of Nutri-Tech Solutions, and the author of 2 books and hundreds of published articles. He runs the popular Nutrition Matters blog and developed the 5-day certificate in nutrition farming course. And he also hosts the Nutrition Farming podcast. So, Graeme, over to you.
Thanks, James. Appreciate it. Nice to chat to you all. It's going to be very difficult to stick to 10 minutes, but I'll do my best. We work in 52 countries with teams of agronomists in most of those countries, and so we do a lot of work in cropping and broadacre generally. And so what I'm talking about today are the trace minerals, or the minerals that are most commonly missing in most of those soils. It's really, really common. There's sort of 5 things I'm going to talk about. I'll begin with the trace mineral boron, understanding that on a soil test, you need between 1 and 3 parts per million, and about 2% of soils we look at even have the 1 part per million. Most people have half a part per million, so it's a huge deficiency. It's a very leachable anion, so anions are only stored on the humus colloid in the soil. Of course, we've lost 2/3 of our humus in the last 10 decades, and consequently, boron deficiency is everywhere. Now, just talking about the role of this thing, calcium we talk about as the single most important mineral because it governs the uptake of 7 others, but calcium simply doesn't work in the absence of boron. Multiple levels, even calcium's role in cell division and quality and so forth is driven by boron. Probably most importantly, very importantly from a resilience perspective, there's a substance, kind of a barrier, a wall called calcium pectate that really protects you from fungal disease and insects. And calcium pectate's made from boron and calcium. So it's not just calcium, it's critical, that boron component. It's really, really important when we look at cropping scenarios, but the timing is before a kilo of sodium borate with some humic acid, always combine humic acid with boron because and humic acid also increases the uptake by a third. So always that creates a boron humate, which is much better uptaken. But the key time is before flowering. So, what we're talking about is whether you fill that grain head. We're talking about the length of the male pollen tube, which really has an impact on pollination. So really, really important. It's also often neglected in pastures. I think, well, we're not growing grains, what do we have to worry about that for? And what we see is that it's really, really important for nitrogen fixation, for leguminous fixation or free living fixation. Boron's one of the key 3 minerals that are involved in that equation. And even the conversion of nitrates through to protein is boron and molybdenum. So it's really important, and it's really, most people need to address it and always put humic acid with it. Number 2 is not a trace mineral, it's a major mineral called sulfur, but it's so neglected and so deficient. It's so common to see deficiencies of sulfur. It's almost every soil we look at. We used to get it for free. It came down in the atmosphere with something called acid rain from releases of sulfur dioxide in industry, and then we banned all those emissions, and perhaps we shouldn't have banned them all. Maybe we should have banned 60% or something, because what we're finding is that sulfur is probably the single most important mineral in crop resilience, and we need resilience when we're getting more biotic, which is insects and disease, and abiotic, which is environmental stress, which is a big one. And there's just a multiple sulfur-based compounds that protect that plant in those scenarios, and sulfur is just lacking everywhere. I even think that pasture dieback's got a sulfur link, but we won't sort of have time to discuss that. It's held by humus. We don't have the humus we used to have. The debate becomes how you put it out there. Now, if you need calcium as well, then gypsum has a role to play, but often you don't need calcium. And often there's actually, in pasture scenarios, for example, I see more benefit in using elemental sulfur, the yellow granules, because you paint the paddock green as if you put urea out there. And it's to do with during the release of that granule, which involves a variety of different bacterial species that create the sulfur and turn it into the sulfate that available form. There's actually a release of sulfur dioxide during that conversion, and the little mouths on the underside of the plant suck up the sulfur and turn that paddock green. It's a really nice response and really worth investigating. A great trick or tip, if you've discovered the potential of foliar spraying urea, and understanding, we won't go through that, we've got time with how and why the mechanics of that work so efficiently. There's a really good thing to put 700 grams per litre of urea and 500 grams per litre of ammonium sulfate, and they combine, and you can get that much in there, so it becomes about a 40% nitrogen that you've created. We actually use something called Fulvex, which is humic and fulvic together, because humic won't work with the ammonium sulfate, it falls out of solution. So we use half a kilo of Fulvex into that scenario, and a little bit of amino acid. There's some tremendous research showing that urea foliar sprays work so much better with just a little touch of amino acids in the spray. So that is one way to address sulfur so efficiently through the leaf. Molybdenum, I'm not sure if I'm going time, but let's check here. Yeah, we'll keep moving. Molybdenum's the next one. Now, 80% of the soils that we look at in all of those countries we work are deficient in this little trace mineral called molybdenum. If you need 0.5 part per million, most people have got, sometimes, many times it's not even measurable, but most times it's 0.2 or 0.1 or whatever. Hugely important for 2 things. Number one, you want to be accessing what I call the free gift, which is the 74,000 tonnes of nitrogen gas that hover above every hectare. We're talking 5,000 truckloads of urea equivalent that's sitting in that atmosphere. The most abundant gas in the atmosphere is nitrogen, and you want some of that in your crop, and you can't get it without this little trace mineral. And 80% of people don't have it, so they're more dependent on nitrogen from the bag. So why is that? Because the enzyme, the nitrogenase or nitrogenase, plants different places in different ways. That enzyme is made from molybdenum. So without it, you simply don't get the access to the free gift, that massive amount of nitrogen. Now, there's a second process which is almost as important, and that's conversion of nitrates. When you use urea, for example, in the soil, most of it goes into the nitrate form, then it needs to be converted to what you want and what your animals want, if there's livestock involved. And that, of course, is protein. So we're talking about converting nitrates to protein, and it's an enzyme called the nitrate reductase enzyme, and it's made from molybdenum. So if you're lacking that trace mineral, and 80% of you are, you can't convert nitrates to protein. Your animals are not eating the protein they should be, and neither are the people consuming that food. So it's hugely important in that context. And if you're going to use a nitrogen-fixing inoculum, make sure you've got a little touch of molybdenum. We're talking 100 grams of sodium molybdate per hectare as a foliar. The big telling point with molybdenum is you dig up, check that you've got nodulation. If you don't, that's sulfur usually. You've got no nodulation on the legumes. That's a sulfur deficiency, and then you need to have that red pigment called leg hemoglobin inside those nodules. And if it's a small nodule, you squash it onto a piece of white paper and you need to see a reddish brown stain. And if you haven't got that, and over half of you don't have it, that's a lack of molybdenum is the primary cause of that lack of red pigment, which means you're not fixing nitrogen, which means you're not having an acid exudate that breaks calcium and phosphate apart, and you're not feeding beneficial fungi because they hang out beneath legumes because they love that acid exudate, which only happens if the red pigment's present. So silica is the next one in my limited time that I've got with you. Silica is not considered to be an essential nutrient, but there have been 10 international silica conferences in the last 9 years, and there's big talk about changing that story. What we understand about silica is that you need 100 parts per million on a soil test in a form called monosilicic acid, and most people have got 10, 20, 30, and organic growers have got double that. Most of them don't have the 100, but they've got double conventional. So what we now know is that glyphosate is probably the biggest cause of that, because it kills an organism on contact called Pseudomonas fluorescens, and Pseudomonas fluorescens is the organism that protects from take-all, for example, in wheat crops. But more importantly, it's the most powerful of a group of organisms that have been recently identified as silica solubilizing organisms that turn the element of silica into monosilicic acid that plants can access. So it's been quite a price to pay when you've knocked out that organism. So we sort of teach you how you can multiply them up on farm and get them back out there and getting that silica back in there. But what's important about it? Well, you're going to be proactive with disease protection. It's about cell strength. And cell strength is calcium and silica equally important. So the strength of the cell wall, which determines how easily a disease organism drills through to get to the yolk in the center of the cell called the cytoplasm, or the sap-sucking insect does the same thing. It's got to crunch through that cell wall. You strengthen the cell wall, you form the barrier, and that's calcium and silica equally important. And then the new findings of silica, that it's a really, really powerhouse immunoliciter. And what's cool about anything that boosts plant immunity is that it boosts yield as well. So it's kind of an ultimate win-win scenario. Now, diatomaceous earth, which you can put down through liquid inject, is one way. Potassium silicate, a foliar liquid form of silica to address that deficiency. And finally, zinc. Probably the biggest single investment if you're zinc deficient is just a seed treatment with zinc, because you get more cost to benefit ratio, more bang for your dollar for that $2 or $1 per hectare from anything else you'll do, because zinc governs leaf size. It governs the production of an auxin hormone that governs leaf size. And so any kind of zinc deficiency is a smaller leaf than what you need, which means a smaller solar panel, less productivity and less profitability. So it's hugely important trace mineral. It's also called the drought mineral because it increases the uptake of moisture, and most broadacre soils that we look at are lacking zinc. So that concludes my little short 10 minutes, and we'll take some questions now.
Congratulations, Graeme, for that amazing condensed thing. You've covered boron, sulfur, moly, silica, zinc,
Yes.
a few other things. Please put your questions in the chat and try and keep them concise. We're here for you. The sessions are for you, and everybody gets great value out of your questions. So, fire away questions for Graeme. This is your opportunity to benefit from his amazing knowledge. I think, we haven't got a question just yet. Graeme, would you like to spend a moment longer Oh, wait, here's a question from Jessica. She says we're using a small amount of Flexi-N in our SE14 soil wetter down the chute at seeding this year, and we've not used this before. What would be a good addition to this liquid mix? We will already be dressing our seeds with fulvic acid, a mixed biostimulant with kelp and trace elements, zinc and vermicast extract. So what would be a good addition to that mix, Graeme?
To the Flexi-N specifically. So the Flexi-N, I'm not familiar with is it ammonium nitrate and urea together? Is that correct? So what Flexi-N usually is. There are a variety of product names for that mixture. Is that what it is? Does anyone know?
Yes.
It is, yeah. On all honesty, if you want to have the benefit of the amine form of nitrogen, which is what urea is, you're sort of kind of taking one hand and giving the other, using these blends of ammonium nitrate with much less urea, and you're far better off using straight urea as a foliar, or in any form, as long as it's complexed with humic acid. And I mentioned that sort of new finding that I've found really effective on my farms. I've got 2 farms, which is combining that ammonium sulfate, because everything needs sulfur, and it doesn't detract from the functional role of urea in your foliar spray, which is the amine going directly into the leaf and converting super efficiently through to an amino acid and a protein. It's just like the most efficient way you never put out nitrogen, but you kind of counteracting that, putting nitrate with it. It's not a good foliar, that combination of ammonium nitrate and urea. In fact, we've trialled it in various scenarios, including in Saskatchewan, in the broadacre work that we do, and it doesn't hold. It's nothing compared to urea by itself or urea with ammonium sulfate.
Thanks very much, Graeme. Adam has a question. What are your views on the use of wood vinegar in agriculture in a broadacre crop production context?
Yeah, it's wonderful stuff. I'm convinced that it will be one of the sort of top 5 or 6 sort of essentials in this regenerative movement at some point. There's some research on its potential. Yeah, it's a biostimulant, a really powerful one. It has this kind of insecticidal and fungicidal effect. It has a plant stimulation effect. I mean, understand you're taking the smoke from making biochar and, obviously in a closed container, and you're condensing that smoke. So all the volatile components in that wood that you're burning, and there's over 200 of them, end up, and one of them happens to be acetic acid, against the name wood vinegar. But there's hundreds of compounds, there's phenolic compounds, all sorts of things. Some of it's a little bit similar to fulvic acid, but there's these things called carrageenans, and carrac is the Aboriginal word for smoke. And we know that part of the cold burning was the smoke triggered some of the natives that only germinated in the presence of smoke. But what we found with this group of compounds that are called carrageenans after the Aboriginal word actually stimulates all seed production. So it's a wonderful seed treatment. You just get a really, really high germination rate and a really nice kickstart with wood vinegar as a seed treatment. So I'm a huge fan of it.
Thanks, Graeme. Another question that sounds like a fairly broad one. What can bricks tell me about micronutrients?
Okay, so bricks levels is a measure. You're taking a garlic crusher or whatever device you use to extract some sap from the leaf, and you usually use the first fully developed leaf, same as what you do a leaf test. Seems to be the guidance to where most things are happening in that first fully developed leaf. So that's what you're going to use for bricks, for measuring your bricks. And you're measuring the dissolved solids. You're measuring your skills as a chlorophyll manager effectively, because you're measuring obviously sugars, which is how well you're photosynthesizing. The higher the sugars, the better. But you're also measuring amino acids and a variety of other things. It's a tremendously simple guideline as to your skills at one of the most important roles that you've got. You're managing 2 things primarily when you're growing anything. You're managing chlorophyll, that green pigment that determines productivity. So you're a chlorophyll manager, and you're managing gas exchange. Gas exchange is how freely does oxygen move into the soil and how freely does CO2 move out. And of course, the plant leaves waiting its closing mouths to stone, that saps up the CO2. And that's the basis of photosynthesis, and that's how you grow stuff. So the better your soil breathes, the better it does, essentially. I've started digressing so much I can't even remember the question. What's the question again? Sorry. Just repeat that question again, because I missed the key of the question.
What can bricks tell me about micronutrients?
Oh, yeah. So bricks normally, the 2 most important minerals are phosphate and calcium for bricks. There's potassium plays a role because it transports sugars around the place. When we talk about trace minerals, I mean, they all play a role because basically you're talking about chlorophyll management, and whether it's zinc or manganese or copper, they all give you the pale colours of blotches and stripes and so forth that determine how well you photosynthesize. And it's called chlorosis when you've got those blotches and pale colours and stripes, which means you've got less sugar factors, less sugar production, and lower bricks. So obviously they play quite a huge role in that context.
Thanks, Graeme. Dom was asked if soils are showing a P deficiency and a pasture test, also showing low P. What fungi-friendly options are there for applying phosphorus? Are there as a foliar or soil? So
okay, so the foliar is really limited, unfortunately, because almost everything foliar is a good option, but for P it's not, because the only source of soluble P is based on phosphoric acid, and so you can use very little. It's a major mineral. It's one of the top 3 minerals in the plant, 3 or 4 minerals in the plant, and you can't get much in there. That's the problem. It's still a benefit, but everything that's soluble in the phosphate form is based on phosphoric acid and will burn. So that's the issue. So the story becomes, when you do a soil test, you measure your total phosphate, and that's a hugely important thing. You only have to do it once, just to know what reserves you've got. Understanding the 3/4 of everything you've ever used in the way of water-soluble phosphate is locked up in what's called the totals, the frozen reserves. And if you find that sometimes, if you haven't had a phosphate history and you've got a low P soil, you're not going to have anything locked up. So there's no point in saying, like some of the people saying, oh, you don't need anything with microbes. Well, yeah, if there's a reserve there, and often there's not in these old Australian soils. So if you've had a phosphate history, phosphate fertilizer, you'll always have phosphate tied up. And that's when you can use biology, and you can use both fungi and bacteria. There are phosphate solubilizing bacteria. I mentioned Pseudomonas fluorescens. There's something called azotobacter. These are all things you can brew and put out through liquid injector, foliar spray them out, and really start releasing phosphorus. There's azotobacter, there's a variety of beneficial bacillus strains, all of which, and then of course we've got the fungi. If you can get some mycorrhizal fungi on the principal reason the plant feeds this little, it's almost like a parasite stuck on its roots, but it gives more than what it takes. There's 10 times root extension, allows the plant to reach out. Phosphate's the most immobile mineral in the soil, so it doesn't move around in soil solution. So this huge extension with these mycorrhizal fungi on your roots gives you access to phosphate you wouldn't otherwise access. And of course, the mycorrhizal fungi are spitting out these acid exudates that break the bond, because the big problem with phosphate, it's got 3 negative charges. The moment you put it out there, DAP, MAP, it begins looking for positively charged minerals, usually calcium, but in red soils, iron is the reason for that red colour. And iron has 3 positives and phosphate has 3 negatives, and that's a mountain magnet and very hard to pull apart. In 3 weeks after applying the DAP, the vast majority of it is already locked up in that frozen form. So that's where the biology comes in to release those frozen reserves. And as I mentioned, the problem with Pseudomonas fluorescens, which does it really well, along with solubilizing silica, is that it's killed by glyphosate. So that's just one of the downsides of that model.
Graeme, we're going to stick with phosphorus for a little bit. Peter says they have low P in their soil test prior to an upcoming faba bean crop.
Yeah.
It's a 12 to 20 Colwell and 60 to 90 with the phosphorus buffering index.
Yeah.
And he says BSES, I'm actually not familiar with that acronym, is 50 to 60.
Yeah.
How important is it to supply phosphorus pre-plant, and should we be supplying the potential 12 to 15 kilos that we'll be removing with the crop?
I would, in that instance, yeah. I mean, a little bit of phosphate as a starter is always, worthwhile. Often we use a lot more than what's necessary, but a little bit's fair. But you've just got to be aware that you're not putting too much nitrogen in the equation with the legume, because it really does. It is counterproductive to have nitrogen supplies to legumes. They're supposed to be getting that themselves, and they tend to shut down their own nitrogen fixation to some degree if you apply nitrogen. So if you're putting on higher rates of DAP and MAP, both of which have got that nitrogen component, you've got that sort of price that you pay for that. So one of the things you can use is things like micronized guano, which is really good. It's really effective, and it doesn't compromise mycorrhizal fungi, so that's one option. But you can also do simple things like azotobacter. You can brew them on farm and you can put them on the seed, and it's $1 a hectare basically when you do that. and they'll stay with the plant for the entire life cycle. And they do two things. They do 10 things, but two of the big ones are they fix nitrogen, they solubilize phosphorus. They constantly solubilize phosphorus. And of course, putting microbes of fungi on the harvesting seeds gives you a really good delivery of phosphate. And again, you haven't mentioned the totals because you've not measured totals from the measurements you've given. But the totals are a good indication of what you've got to mine, and that's where you can use microbes of fungi and phosphate solubilizing bacteria very, very effectively to access some of those frozen reserves.
Graeme, can you clarify what that acronym is, BSES? I mean,
there's a whole variety of phosphate. There's coal and there's bray, and I actually like something called malic-3 and there's BSES. So there's a whole variety. I find the malic-3, which is one of the ways you can measure phosphate, using the guideline of how it correlates to leaf testing. I find it has in most, in a greater variety of soil tests, it correlates more closely with what you can see in the leaf. So I just like that particular way of monitoring phosphate. The idea of having to replace what you've taken off, if you've done totals and you know that you've got 2,000 parts per million of phosphate tied up there, it's really nonsense to say, I've got to put it back. You've got to release what you've got. It's a hell of a lot cheaper way of doing it, but you need to know what you've got. That's why it's so important to test totals.
Yeah, thank you. Rob C has asked if he can mix powdered boron with prilled humic acid when it's going down the chute with multi-species pasture.
Usually you solubilize the boron first. Like usually it's going to be sodium borate's the most common thing. That's really important because you form this boron humic and you combine humic acid and boron together. But there's two types of boron. There's sodium borate and boric acid. And boric acid doesn't go with humic acid because humic acid is a weird acid that's only soluble in alkaline conditions. So they actually use potassium hydroxide to extract it from certain types of brown coal. So all humic acid is what's called a potassium humate, which is quite alkaline, but a pH of 11. So it doesn't go with anything acidic. And so boric acid is not compatible. Now, there is, one of our things, and I don't know from our products, but we have a product called Fulvex, which is half humic, half fulvic. And that's what I'm suggesting you use with that combination of ammonium sulfate and urea because it's compatible. So we found a way to make humic acid compatible with everything when it's at first. And so it's half fulvic and half humic, and you put it with anything. So all the people fertigating, you put little amounts of it to collate and magnify whatever they're putting out there, and we do the same thing with foliar and liquid injected broadacre.
Okay. Another question about products down the chute at seeding. Jessica is trialing granulated calcium carbonate, and they've put lime out in previous years. What's your experience putting calcium at the root zone?
Well, it needs to be, it depends on which product it is, but it really needs to be super fine. I mean, the whole kick-in factor of calcium carbonate is how fine it is, and so we're really big fans of this micronized concept. So we do micronized magnesite, micronized lime, and micronized dolomite, micronized gypsum, and they're down to 5 microns, and that's just like an instant root response. And calcium, even just a little micronized calcium on the seed, like a lot of people will treat their seed with some biology and perhaps some trace metals, always including manganese and zinc, and there'll be something like kelp for the hormonal component and so forth as a seed treatment. And then you usually limit it to 10 litres per tonne of seed because it gets too wet. It could be more than that, but people take it to 20 litres, so now it's a bit sticky, and then they dust micronized lime or even micronized guano, which has 35% calcium in it, onto that seed, and it sucks it up and forms this really nice seed coating on there because it hardens up and sticks onto the over-moist seed, and so then it's completely free seed that you can plant with, and you've got that calcium kick. But you see some tremendous results with that superfine lime on the seed. Plants seem to love that available source of calcium right at the start like that.
Yeah, I've done that myself at a small scale, Graeme. I understand what you mean there.
Yeah.
Just let everybody know that we've got plenty of capacity for more questions. Alex has asked this question, says they had their last rain in December. How do any microbes survive?
Okay, good question. If there's plants alive, there's microbes alive. I understand the whole deal is that if you're checking soil life, everything's gathered around that plant. The plant's feeding to sort of like there's enough moisture to keep the plant alive, there's enough moisture to keep the microbes alive, and most of them, I mean, if you use something like a microbiometer, a little tool that measures total microbial biomass, which is an invaluable, essential tool in my opinion, because that's basically the same happens for the workforce, and the bigger it is, the better you do. It's as simple as that. But you're taking the soil directly from the roots of the plant, and you'll find that if you take that soil and then you go where there aren't any plants, that's why you want to have good ground cover, because the plants are feeding the microbes, and wherever there's not ground cover, there's much lower levels of soil life. And you can do that for yourself. You take the soil from the roots, and then you take it from where there's a bare patch, and there's hundreds of times less microbes. They're hanging around the plant's feeding them 30% of its sugar. If there's a live plant, there's a live microbe. Now, if it's completely droughted out, which you described, it's getting pretty dry, they don't die. Some do, but most of them, many of the bacteria can form cysts or spores, and they just go into that. When they're stretched, they go into that form, and they back to rain, and then they spring back into life. And you can say, yeah, from that perspective, it's not too much of an issue.
Great, thank you. I've wondered that myself. Matt has asked the question: where would you include liquid sea minerals in the process? Okay,
so I think that I'm just starting to play around with them on my farm. I think that the key to them, I'm finding, is you put humic acid with them, and then you've got the carbon component to create all the carbon complexing of things like that vascular dry. I mean, what we're talking about is that the first cell that is from the pre-Cambrian ocean had 74 minerals, which is that's what's in seawater, and you know we've identified 40 to 50 minerals we work with, but the reality of in the perfect blueprint called nature, there's no accidents. If there's 74 minerals, then they've got a role. And they're increasingly discovering there's some work in the West Australian University last year using 3 rare earth minerals I've never even heard of before, and seeing this really tremendous seed treatment response of them. So basically, we're covering all the things that we wouldn't otherwise cover with the seed minerals. And if you put humic acid with them, you create that carbon bond and collate them with the humic acid, then they've actually got, you know, you're only using small amounts of foliars and so forth. They've got some tremendous potential, in my opinion.
Lucy has asked, are there any tricks to dissolving urea to make a foliar spray? They're using a 1,500 litre spray rig. What rate of urea per hectare would you use? What else would you add to the basics?
I'll give you an example, because one of the recent times when I spoke at the Victorian No-Till conference in Victoria, we were at Grant Sims' place for a field day, and Grant was sort of describing all the practical things that he does, and he's doing a great job on that 3,000 hectares. And I was sort of talking about why you do it, and how it works, and why it works, and so forth for the day. But he was demonstrating how he dissolves his urea, just to give you an idea on that kind of scale. So he's got a 30,000 litre tank. He half fills that 30,000 litre tank with water, and then he continues filling it while he does this next process I'll describe. So he's using a finger auger, and he puts 8 tonnes of urea into 30,000 litres, which is roughly a 1 to 4, which is a nice easy way to dissolve it at 1 to 4. And he's got this finger auger delivering the urea up into the top of the tank, and then he's got a trash pump connected to the bottom outlet of this tank, and you can hear the urea rattling around in the pump as it's pumping through and pumping it back into the top and circulating it and fast-tracking the dissolving of it. Right? So by the time, you know, obviously you can modulate the speed at which you're filling the second half of that tank, but he's got that being filled from the external source, while this finger auger is delivering urea, and the trash pump sucking it through and pumping it back through. And by the time he gets to the top, the urea is dissolved, and he's got he applies that at 60 litres per hectare, that 1 to 4 rate. But he puts this humic acid in at the end, so it creates what's called the urea humate, and he puts that out at 60 litres a hectare twice during the crop cycle, sometimes 3 if it's needed, but usually twice. So that's equivalent to 15 kilos of urea per hectare, and it's quite important, the urea component, because that's high nitrogen. If you do the sums, and he's just putting 60 litres of water out there, really, with that high percentage of nitrogen, that 4 to 1 urea mix in there, and that, you know, some crops that can burn. So the humic acid buffers that potential burn, and it gives a very, very nice nitrogen response.
I just want to let people know that our practice guide on the use of foliar sprays is available, and we've got lots of information in there which might be a great thing to download and have a look at. Graeme, I wonder if you could just give a little bit more info before we go on to the next question on that issue of leaf burn.
Okay, well, it's just, obviously different crops will respond differently. I mean, if you're dealing with micro vegetables on one of my farms, along with apples and garlic and stonefruit and so forth on that farm, and there are some things that you can't do 15 kilos. I mean, cereal crops are much hardier than, say, even a tomato or a capsicum or something like that. And so we'll pull back to 10 kilos of urea as a foliar. I'll just quickly explain. I mean, most of you probably heard if you've listened to my podcast or more recently the video series. There's a video series called the How to Do It series where I teach you how to do, azotobacter for your own nitrogen fixation or pseudomonas to release phosphorus, and how you can even grow your own mycorrhizal fungi. All of these things are taught on that series. And it's ridiculous, but we've just translated them to 8 languages. So I'm speaking, and my mouth's changing, and I'm speaking Hindu and Mandarin, and we've got people who speak Hindu and Mandarin that checked it, and it's like perfect. And how the hell did they do that? But anyway, that's what we're doing with that series. That's a learning opportunity we've not discovered the How to Do It series, with the new seed that we're actually filming later this afternoon tomorrow to do the next series of that. Back to repeat the question again.
Just a little bit more detail on leaf burn with nitrogen.
Yeah, so the issue is different plants respond differently, and the importance of the humic acid, aside from the fact that it creates that thing called urea humate, which is taken more efficiently and stabilised anything that doesn't go into the leaf. It also buffers. It's a very dense carbon material. I mean, you can use other carbon materials. You could use molasses, I guess, which is a dense carbon-based material, just to try and buffer. There is an issue with, the deal with urea is that, it's been demonised by organic people in some instances and so forth, but the reality is it's a natural compound. It's exactly the same compound that's found in urine. And if you go to India, the principal source of nitrogen on cropping is cow urine. None of it's wasted. The cows come in, at night, these sacred cows that are walking the streets have all got a home. They go home at night. They've got a sloping concrete floor. The urine rushes down into a guttering that goes into 1,000-litre tanks, and that becomes, sometimes they put a bit of something equivalent to our BAM or EM, a sort of lactate fermentation. Sometimes they use it raw, but they foliar spread it as their primary nitrogen source. It's the highest nitrogen is the urine. Of course, we waste, you see that big green patch in the paddock from that urea source. There's nothing different than what we've extracted. We've used this very energy-intensive process called the Haber-Bosch technique to haul it out of the atmosphere and convert it to urea. But it's the same compound, except, and that's how organic people get caught if they cheat, is that it has this thing called bioret as a side effect. And so bioret can burn. So like citrus are really, really susceptible. They love foliar urea, but you've got to use low bioret urea, or you'll burn them, because it's actually the bioret that's burning. And that's, again, humic acid can sort of stop that, but if it's a sensitive plant, that's the issue. It's the bioret, and you can get low biurea if you've got a plant that burns, and you still want to have that benefit of polished-grain urea.
Thanks, Graeme. Robert has a question about foliars, and he says they have a series of soil and plant tissue tests that indicate low sulfur and low potassium levels. Can they be addressed adequately with foliars, or should they use potassium sulfate granules? This is in a broadacre multi-species pasture situation. Okay,
so we've had some tremendous results with just using potassium sulfate. See, the deal with potassium sulfate, which covers both of those things, that's kind of perfect. The deal with potassium sulfate is that it's got this low solubility rate. So, urea is 1 kilo to 1 litre. In fact, slightly more than that you can get into dissolve in a litre. But potassium sulfate's 10 kilos, 1 kilo per 10 litres of water. So if you use 100 litres in a broadacre scenario, which is a common kind of rate, and you use 8 kilos, which is what we find works best as a foliar, and you put some fulvic acid with it, you can't use humic because it's not compatible because of the sulfur component, it's acidic. You could use that fulvic that I mentioned, but otherwise you put fulvic with it. And that increases, fulvic and humic both do the same thing. It's called cell sensitization. It's called increasing the permeability of the cell membranes And there are multiple papers that show you get about a third better response. You uptake a third more when you combine either humic or fulvic. And the limitation is whether it's acidic, because you can't put humic with acidic things. So you put a bit of fulvic acid with your potassium sulfate at 8 kilos per hectare. And of course, what happens in dryland scenarios, and you've all seen it, potassium is basically the second most abundant mineral behind nitrogen, but the most mobile. So it rushes around really quick. And basically, it'll leave the lower leaves as soon as you start getting deficient. And what happens is when you get deficient is a dry finish in boilermaker scenarios, because basically it's only in soil solution. Like nitrogen's coming in, you can have organisms on the leaf that can fix nitrogen from the atmosphere directly, and it's not, even though it's the most abundant and super mobile nitrogen, it's not so dependent on there being soil solution, whereas potassium is completely dependent. Plants taking potassium out of soil solution. You've got no solid soil solution, you've got none of the second most abundant mineral, and that shows up as a burnt outer margin on the lower leaves, because the plant sucks from the lower leaves to satisfy the growing tips and the size of the grain, which is hugely important, the role of potassium. So potassium sulfate in that latter half of the season, you've got the sulfur for the protein, and you've got potassium, to gain its grain size. It's a money mineral for it. That's a really, really good strategy. 8 kilos of potassium sulfate, foliar sprayed with 100 litres per hectare.
We've got about 13 roughly more minutes for questions, and whilst I'm waiting for one to come in for the audience, my colleague Talia has suggested that, Graeme, maybe you could give a summary of the strengths and weaknesses of foliars and what focus people should think about in relation to soil health alongside the use of foliars.
Okay, so the story with foliars is that, interestingly, there is a link between foliars and soil health, because essentially understanding that the plant, in recognition of the importance of the life beneath its feet, gives away 30% of its most important substance, which of course is the glucose it makes in photosynthesis, which it combines with minerals for everything. It's the single most important substance. And a third of that total glucose that it produces, or 30% of it spits out from its roots to feed the surrounding organisms. So, it understands how important they are. I look after you, you look after me, is the deal. Give and you shall receive is very much the model there. Sorry. Yeah, so that importance is huge. And when you foliar spray and you fast track, because foliar spray is 12 times more effective than putting it through the soil on average. And so when you foliar spray, particularly trace minerals, which if you're lacking, you've got some pale colours and blotches and stripes, you've got chlorosis or a lack of chlorophyll, and you fast track so much more efficiently the greening of that plant, you've got more chlorophyll, you've got more sugar production, you've got more feeding of that sugar, that 30% sugar for the roots and the soil life says you beauty, so it's a great response. The foliar can look after soil life in that context. But the other sort of simple rules of foliar, like this bunch of misleading things out there. Like there's a good machine called the Talent Turk, comes out of New Zealand, and the Talent Turk's wonderful because you can put solids through it, you can put lime through it, and it's got this massive churning thing that will keep it in suspension and spray it out through these jets. But I've been to field days where they said, "Oh, we can put urea and humic acid out, and you get this aiming straight to leaf that converts straight to the protein," but you're not doing that. It's not a foliar spray with that droplet size. It's really important. You can't use a vermicelli jet and call it a foliar spray. Foliar spray has to be a fine particle that can be uptaken through part of the uptake. In fact, the most important part of the uptake is by the little mouths on the underside of the leaves called the stomates. So not tiny. You've got to have this finer particle. Like you can put liquids through a centre pivot. That's not foliar spray. None of it's going. You can water with a watering can onto your veggie garden, and none of that goes into the leaf. That's going into the soil. It's a soil application. So when people say, I remember being at the National Dairy Convention and talking about urea and how it works as a foliar so much more efficiently than what they're doing with 120 kilos after every grazing, put it on the soil, and most of it's volatilizing and leaching or going into the plant as a nitrate, which is flooding the plant with the nitrate, which is always uptaken with water, which creates substandard pasture and the whole story that goes with that. And I'm talking at this dairy conference, and two blokes stand up and say, "Oh my God, we heard you speak 6 months ago. It's transformed everything. We use 15 to 20 kilos of urea compared to 120. We get a better response, less mastitis, far better herd health. It's been transformational for us." And another bloke stood up and said, "I tried it. It was a load of bloody bullshit." And I said, well, how did you do it? He said, oh, I did the spray. He said, oh, no, I've got a contractor. And I said, how long was the grass? Oh, the contractor said, grade your white down first, just because maybe it's easier for him. But you've got to have 4 inches of growth for it to be a foliar. All you did was put urea on the soil. And of course, it's 15 times or 12 times less efficient. And it doesn't go in the amine form, which is what urea is. See, the deal is you put urea in the soil as an amine, immediately there's a urease enzyme that converts it to the ammonium form, then a bunch of bugs called nitrophine bacteria very quickly convert that to the nitrate form. The nitrate goes in with water always, and the plant doesn't differentiate, it just keeps sucking it in with water. And so if you put on too much urea, then you get this diluted plant with all the water that carries in the nitrate that urea turns into. And then it's, as a nitrate in the leaf, there's this molybdenum-dependent, super energetic process involving the nitrate reductase enzyme that converts, and some say 70% of your whole photosynthetic energy, which could have been in your pocket as yield, is used just to convert the nitrate through to the first stage of protein. And guess what the first stage of protein is called? It's called an amine. What would happen if then it goes click, really easy from an amine, click to an amino acid, and click to a protein? What would happen if you 12 times more efficiently foliar sprayed the amine, which urea starts life as, straight into the leaf, click through to protein? There's nothing comes close in efficiency for nitrogen. And now this idea of putting a little bit of ammonium sulfate with it and some amino acids, which make it work even better, is a really, really good concept.
Thanks, Graeme. We've got 2 more questions, and it might be all we have time for. We'll see how we go. So one of them is about, building on what you were just saying there. Do foliar amendments suffer from having only a short-term effect, whereas soil-based amendments can work more slowly as a slow-release product? This is in a pasture setting.
Yeah, so you've sort of got a couple of things happening with your foliar spraying, and you're getting this chlorophyll density, and you're getting more photosynthesis, and you're feeding the bugs that are then releasing things from your frozen reserves, which is that measure of the totals. You've got that ongoing sort of response. But generally speaking, if it's something like if you need lime, if you need calcium, for example, it's really, really important. It's a foundation mineral. It governs the uptake of 7 other minerals. And if you need lime, you can, spray a bit of calcium nitrate or whatever as a foliar with a bit of fulvic acid. It can be quite expensive to supply the plant's immediate needs, but you're far better off in terms of what lime does in the soil, what calcium does in the soil, which of course is this very large ion the size of a beach ball, if you thought of it like that. It's obviously not that size, but compared to magnesium, which is a golf ball, and it's got 2 charges, and it grabs hold of clay on either side, because clay holds on to calcium with its negative charges, and it pushes apart that clay, and that's called flocculation. So calcium governs pushing the part of the clay apart and how well the oxygen comes in. The most important single element is not N, it's not P, it's not K, it's not calcium. It's the most important element for all life on the planet is oxygen. And so calcium determines, does oxygen get in there freely to supply fuse, which means it moves from a high concentration to a low concentration from the atmosphere into the soil, where the organisms say yes, because they need it, and the roots need it for everything. Then they use it, and they breathe out CO2 just like we do. And then the CO2 uses, which means moves from a high concentration to a low concentration into the atmosphere. The plant leaves waiting, captures that CO2 through its stomates, mixes it with water and sunlight, and that's how you grow stuff. That's called gas exchange, oxygen and CO2 out, and calcium determines that. So there's no point, it's far, far better in that instance for calcium in the soil and fix the thing, is the story.
Graeme, building on the comments that you were making about putting stuff on with a watering can or a pivot not being that successful, what is the right nozzle size to get 200
microns is sort of the figure. If you go to whatever that comes down to, 200 microns is the particle size that goes in nicely. Something you can go even lower, you can go to 150 to 200 works. So, it might be possible, even with that time fix, I'm not an investigator because I don't have one of them, but you might be able to find nozzles where obviously you'd have to change nozzles because you couldn't put lime through them or manure or all these things that you can use those time fix for. You've got to have a big nozzle for that. That's why it's made good for a foliar, but maybe you can change the nozzles and turn it into a foliar rig, so you've got the best of both worlds, but you have to swap them over each time depending on your job. So your 200 microns is a particle size.
I think we've got time for one last question. If anybody can quickly pop a question into the chat, then we'll ask that. Otherwise, we'll move to summarize everything that's been said. Robert has come in with a question. What sort of levels are required in a totals soil test for sulfur and potassium for there to be sufficient biology?
It's a hard one because it depends totally on the type of soil. So, lighter soils can have much lower amounts of totals and so forth. So there's not, ideally, on our soil therapy program, I'll just put the note that if you keep your eyes out, there's going to be an app that we're releasing shortly. If any of you are interested as farmers in road testing, what's called beta testing, this new NTS app, just to give you some ideas of the function, there's a really good farm management program on there. There's automatic conversion of any leaf test. You can scan the data in there and it'll convert it through to soil therapy. And our plant therapy, particularly our leaf, we call plant therapy leaf testing, gives you the crop-specific guidelines for a couple hundred crops, so you know where you need to be. The problem with a lot of testing is you don't know what the guidelines are, and that's really common with totals. Well, our totals do give you the guidelines based on how much clay and how much sand you put on that soil, and where would be a good level to have totals. And that's all available on that app. There's also 15,000 pages of my life's work that's gone in there. So I've cloned myself. It's called Ask G-Man. So it's an AI thing that actually writes in my style, and it's ridiculous. You just ask any question on human health or soil health in the 2 segments, and you get this detailed response. So that's all part of the app that's called GROW, the NTS Grow app. G for guidance, R for resilience, O for organisation, and W for wisdom. And that's that. If anyone's interested, just contact me. You can be on the list of people who can road test it for us.
Oh, amazing, Graeme. Look, I'm looking at some of the notes that we've taken about the things that we've covered. Nitrogen, different forms of nitrogen, wood vinegar, micronutrients, phosphorus, a few questions on phosphorus, boron and humic acid, more about calcium, how microbes survive in drought, sea minerals, dissolving urea, sulfur and potassium, and again, questions about foliars. Does anything come to mind for you, Graeme, and all of the things that we've talked about that you would just go over for a couple of minutes, or you wanted to, is interesting to you that was the nature of questions?
Well, I'm convinced that there's a huge future. I mean, obviously the issue becomes that we're putting more and more on the conventional model in the local industrial agriculture. The fatal flaw is that it's a symptom treating model, and it's no different than medicine, where we just discovered that largest killer is heart disease, second is cancer, and the third, it used to be stroke, the new third is prescription medicine. And that's the same indication of a bankrupt symptom treating model, when your medicine, for God's sakes, become the third largest killer. While in agriculture, more chemicals every year for 10 decades, 14.7% last year, 14.4, 14.1, 13.9, every year, more and more. And every year, globally, more and more pest and disease pressure. That's a hiding to nothing. That's a definition of unsustainable. So one of the things that I'm seeing that is tremendous about is you're trying to do things cheaper. So seed treatments are a no-brainer. Put microbes and minerals on that seed and stimulants like kelp with the hormones in it. And you'll get this response for such a tiny investment that is unparalleled. Foliar spraying, huge, stabilizing nitrogen and so forth. And phosphorus, forming a phosphate humate when you put it with the humic acid granules with your DAP and MAP. They're all no-brainers, but the brewing of your own workforce is what this video series teaches you. And there's so many people in so many countries that are getting into it and getting really, really good results. I mean, I mentioned the Victorian No-Till Field Day. I mean, Grant Sims can produce 160,000 litres of various anaerobic and aerobic brews in one purpose-built shed for his 3,000 hectares. And I mentioned to someone, well, this is one of the biggest things I've seen on farm. And he said, well, we've got someone who can produce, his name is Harry, he runs Tiverton Farms. He said, we can produce 480,000. That's been so successful, we'll have 8 of these plants across the country by this Christmas. So I'm talking about, something that very much a state of the future, shape of the future in terms of low cost, do it yourself. Because, it's another job, I can't do it. There's nothing to it. Watch some of the videos and learn how to do it. It's really simple and really, really productive. Okay. Thank you.
Thank you, Graeme. That's amazing. I'm just going to share something here so that you can all see this QR code, because that will allow you to stay in touch with us. We'll have an email coming out shortly that will update you on everything that's coming up, and also be a little bit of a summary of this. You can download the practice guides, and you can let us know if there are topics that you want to hear about in the future. We'd like to know about that, as we'll work to include them in the remainder of our program for this project, this Cropping Resilience project. So thank you, everybody, for coming along. Hope you have a great afternoon, and we'll see you next time.
Thanks, James.
Thanks, Graeme. Thanks, James.
See you all.
Thanks, everyone.